Good morning. Today we're going over 3.3, which is dividing polynomials, or long division of polynomials, in other words. So to divide polynomials, we use long division as follows. So we're going to say if p and d of x are polynomials with d of x not equaling 0, then there exists a unique polynomials q of x and r of x, where r of x is either 0 or of degree less than the degree of d of x, such that you can divide p of x divided by d of x, and that's going to give you q of x plus the remainder r of x over d of x. This is known as the remainder. Or in other words, you have the dividend. It's going to equal the divisor times the quotient plus the remainder. Now, the polynomials p of x and d of x are called the dividend and divisor, and respectively, and then q of x is the quotient and r of x is the remainder. So for example 1, they want us to divide 6x squared minus 26x plus 12 by x minus 4 and express the result in each of the two forms of division algorithm. So what we're going to do is we're going to do the 6x squared minus 26x plus 12 divided by x minus 4, just like you usually would do it. Now, instead of just doing one number, what we're going to do is we're going to multiply. What can we multiply for the first term to disappear? So we can do 6x in order for the first term to disappear, but we also have to multiply it by the 4. So it's going to be 6x is going to be 24x. And then 6x times x is going to be 6x squared. Now, like usual, you get this, but like usual, you have to subtract. So this becomes a minus, and this becomes a plus. Just like you usually would, you would subtract, but remember the subtraction goes to the entire new equation that you got, not just the first term. So these cancel out. Here you're left with negative 2x. We're going to bring down the 12 and then plus 12. Now, what am I missing to be able to get rid of that negative 2x? Well, I'm going to multiply by negative 2. It's going to be negative 4 times negative 2. It's going to be positive 8. And negative 2 times x is going to be negative 2x. Now, remember, when you subtract, you're subtracting the entire thing. So this will become positive, and this will become negative. So this cancels, and we get 4. This is the remainder, or just r. So your solution is going to be 6x minus 2 plus 4, and then divided by x minus 4. So this is the final solution. So here we have a few examples. We have x cubed minus 2x squared plus 6x minus 6 divided by x minus 3. So I'm going to go ahead and write that in to be able to divide it. And I'm going to divide it by x minus 3. So what I'm going to do is I am going to get that x to equal x cubed. So I'm going to do x squared. So it's going to be negative 3x squared and then x squared. Since I am subtracting everything, this becomes negative, this becomes positive. So when I add them, these cancel. And I'm left with x squared. I can bring down the 6x. And now, what can I do to get that x into an x squared? I'm going to go ahead and add x. So it's going to be negative 3x. And then x squared. Remember, you're subtracting. So this will become negative. This will become positive. So these cancel. And we're left with 9x. I can bring down the 6 to get negative 6. Now, what can I do to get that that x to a 9x? I will multiply by 9. So I'm left with negative 27 and 9x. Remember, the signs flip. This cancels, and we're left with 21 as our remainder. So our solution is x squared plus x plus 9 plus 21 over x minus 3. So I'm going to divide all of these terms. But I want you to note, we don't have an x cubed, so I will be adding right here a 0x cubed. same as right here, we're missing an x, so I will be adding right here a 0x. The reason I'm doing that is for when I divide those cube terms, which will appear, we can work them out so they can also disappear. So I'm going to go ahead and write x to the fourth plus 0x cubed plus 4x squared plus 0x minus 45. I also added a 0x right here because we don't have one. I just want to make sure I go down the problems by degree. So now here we have x squared plus 0x plus 9. So I'm going to go ahead and start. What can I do to get that x squared to the x fourth? I can go ahead and multiply by x squared. So that's going to be 9 times x squared is just 9x squared. This will be 0x cubed. And this will be x to the fourth. Remember, we're subtracting. So all of these become negatives. These cancel. 0x cubed cancels. So I'm not gonna combine anything because they're all zeros. And then we have 4 and negative 9x. That's going to give us negative 9x squared. I can bring down the 0x. And I'm also going to bring down the 45. Now, what can I do to get rid of those numbers? I'm going to go ahead and multiply by negative 5. So I'm going to do 9 times negative 5 is negative 45. Negative 5 times 0 is 0x, and negative 5 times negative 5x squared. When I subtract everything, remember we're subtracting as a whole, so this becomes positive, this becomes negative, and this becomes positive. This one cancels, the second cancels, and the third cancels. For this one, we don't have a remainder, so our solution is just x squared minus 5. Since there's no remainder, we can just leave it there. So for number 4, I have all of the terms, so I'm going to go ahead and just start with the 2x squared minus the 5x plus the 3. And I can divide it by the 2x minus 1. So then I can go ahead and start solving it. I am going to go ahead and multiply it just by an x because I already have the 2x. So this will be a negative x, and this will be a 2x squared. This becomes a negative, this becomes a positive. This one cancels, and we're left with negative 4x. I can bring down the 3. I can go ahead and multiply this by negative 2. So I will get positive 2. And here I will get negative 4x. Remember, since we're subtracting, this becomes positive, this becomes negative. The first term cancels out, and we're left with a 1. 1 being your remainder. So your solution is x minus 2 plus 1 over 2x minus 1. So we have synthetic division. Now we did long division, now we're doing synthetic division. Synthetic division is a quick method of dividing polynomials, and it can be used when the divisor is of the form x minus c, so a term. So in synthetic division, we write only the essential parts of the long division and compare the following long and synthetic divisions in which we divide. So here's 2 examples of a comparison between long division and synthetic division. Long division, which is what we have right here, which is what we just did, you take the whole term and divide it with each other, one term at a time, until you get the quotient and the remainder. Now, synthetic division is going to give you the exact same thing as well. Now, synthetic division is done a little bit different in the sense that you bring down that first number. That's why the 2 is there. And then after you bring it down, you're going to multiply 3 times the 2. That's how we get the 6. Then you add the negative 7 and the 6. That's how we get the 1. And you do 3 times negative 1. That's how we get the negative 3. You add 0 and negative 3. That's how we get that negative 3. You do 3 times negative 3. That's how you get negative 9. You add these and you get the remainder of 4. The remainder is always going to be the very last term. Now note, we are dividing the same problem. What do I mean by that? We are dividing right here. Notice how we have a 2, negative 7, a 0, a 5, and a 5. And here we have a division of x minus 3, and here we have the 3. How do we get that 3? And what happens from one to the other? In the long divisions, we keep all the terms, we keep all the variables. The synthetic division, we only keep the coefficients. And instead of dividing by the entire x minus 3, you do x minus 3 is equal to 0. You get x is equal to 3. That number by itself is what you are dividing with. Not the whole term, like we do long division, just the number. So let's see what it's saying in the bottom. Note that in synthetic division, we abbreviate the equation, the 2x cubed minus 7x squared plus 5, by writing only the coefficients, 2, negative 7, 0, and 5. And instead of x minus 3, we simplify and write 3. So what I just mentioned. So they want us to use synthetic division to divide the 2x cubed minus 2x squared plus 5 is equal, divided by x minus 3. We have to add the 0x in order for us to be able to find it. Now, x minus 3 equal to 0. We get x is equal to 3. So we have the number that we're going to divide it by. Now, we have the 2x cubed, the negative 7x squared, plus the 0x plus the 5. Let's grab the coefficients. So it's 2, negative 7, 0, and 5. Now, I'm going to go ahead and do the division. We're going to get the 3 outside, and I'm going to write 2, negative 7, 0, and 5. I will bring down the 2. Now I'm going to go ahead and multiply. 3 times 2 is positive 6. And then I can go ahead and do, well, negative 7 plus 6, it's going to be negative 1. Now, 3 times negative 1 is going to be negative 3. Negative 3 plus 0 is negative 3. And then positive 3 times negative 3 is negative 9. And then go ahead and add them, we get the 4. Now, keep in mind, if you start with an x cubed, it's going to start with an x squared, then an x, then your constant, and then the remainder. So you're always going to have a smaller x after you divide by degree of 1. So if you start with an x4, your next one is an x cubed. If you start with an x5, after you divide, you're going to get an x to the 4th. You're always going to be 1 degree less. So your final answer is actually going to be 2x squared minus x minus 3 minus 4 over, and here you do write the entire term, just like long division, the x minus 3. All right, so I'm going to rewrite this in standard form. Right? So we have our first term, which is the 1, a second term, which is a negative 5, and our third term, which is a constant, which is 2. In this one, we don't have to add any zeros because we have an x squared, an x to the first, and then no x. Now, let's figure out what term we're going to divide by. So we're going to do x minus 3 is equal to 0. I'll add the 3, and we get to divide by x is equal to 3. So the way I write this is going to be the number that I'm dividing by, and then a long division sign or backwards division signs for you guys. And it's going to be the first coefficient, the second coefficient, and then the constant for this problem. So we're going to bring down that first term, and we get that 1. Then we're going to do the number we got times the number we're dividing by. So it's going to be 1 times the 3. So we're going to get a positive 3. Then we're going to go ahead and add negative 5 plus 3, and that's how we get the negative 2. Then we do 3 times negative 2. That gives us negative 6. So 2 plus negative 6 gives us that negative 4. Since we started with an x squared, my first term is going to be an x. The second term is going to be a constant, and the last term is going to be the remainder. So when I go ahead and write this for the final solution, it's going to be 1x, or just x, then minus 2. And then for the remainder, it's going to be negative 4 divided by x minus 3. And we have to use the whole term instead of just the 3 because they have to match. The long division has to match with the synthetic division. So for number 3, we have the cubed, a squared, and x to the 1 power, and then a plus 6. So we have all of the terms that we need. So let's write down all the coefficients. It's going to be a coefficient of 1, coefficient of -4, coefficient of 1, and a coefficient of 6. And we're going to divide by a 2 because when we do x minus 2 is equal to 0, we get x is equal to 2. So I'm going to go ahead and set up the division. 2, we're going to get 1, -4, 1, and 6. So I'm going to go ahead and bring down that 1. So it's going to be 2 times 1 is 2. And then -4 plus 2 is -2. 2 times -2 is -4. 1 minus 4 is -3. -3 times 2 is -6. And these cancel out and we get 0. So writing the information down, since we start with the cube, we're going to start right here with it squared, with an x, with a constant, and with the remainder. We don't have a remainder this time, which is awesome. So I'm going to go ahead and write the answer as x squared minus 2x minus 3. Since there is no remainder, I can just go ahead and write x squared minus 2x minus 3. So example 4. They want us to find the quotient and remainder when p of x is divided by x plus 2, and then use the remainder theorem to find p of -2. Now, the remainder theorem, it's basically just dividing by that number. So let's figure out what's going on here. For this first one, we can divide by x is equal to -2. And we have an x cubed, we have an x4, we have an x to the third. We don't have an x to the second, so I'm going to go ahead and add it in there. And then we have an x to the first, and then we have a constant. So for a, I'm going to go ahead and write it down. We're going to get a 3x to the fifth plus a 5x to the fourth minus 4x to the third plus 0x squared plus 7x plus 3 divided by x plus 2. We know that these are all the coefficients, and we're going to divide by x is equal to -2, which is what we stated earlier. So when I try to divide this using synthetic division, I'm going to go ahead and do -2. I'm going to go ahead and open the division sign. So we're going to get 3, 5, -4, 0, 7, 3, and then go ahead and start. So we're going to go ahead and move down that 3. So we're going to get 3 times 2 is 6. Sorry, -2 is -6. So I can go ahead and do 5 plus -6 is -1. -2 times -1 is 2. I can go ahead and do -4 plus 2, so it's -2. 2 times -2 is -4. Can go ahead and add 0 and -4, so it's going to be -4. -4 times -2 is 8. Sorry, this is +4. I made a mistake. So we're going to get -8. So 7 plus -8 is -1. And then -2 times -1 is +2. And we get 5. So here we have the x4, the x3, the x2, the x, the constant, and the remainder. So we're going to go ahead and do x4 minus 3x4. 3x4 minus x to the third minus 2x squared plus 4x minus 1 plus 5 over x plus 2, this being the solution. Now, what is the remainder theorem? The remainder theorem is just asking you to divide by that number and then figure out what the remainder is. So when we have this remainder theorem, we're going to do the same thing. It's going to be 3, 5, -4, 0, 7, and 3. This is for B. And they're asking you to do it by -2. So we're going to go ahead and do -2. Now, we're going to get the same thing because they are the same number. So I'm going to go ahead and bring down the 3. 3 times -2 is -6. -1, +2, -2, +4, +4, -8, -1, 2, 5. So since they want the remainder theorem, the way you would write the solution is after you do the synthetic division, you would just do p -2, is equal to 5. That will be the remainder theorem, how you would write this final answer. So the remainder and factor theorems. The next theorem says that zeros of polynomials correspond to factors. So factor theorem, C is a zero of P if and only if x minus C is a factor of P of x. What does this mean? That if you have a factor of a polynomial, and you do synthetic division, if it is a factor, you will get a remainder that equals 0. If it's not a factor, your remainder will not be 0. This is all this means. So when it's asking you to do the remainder theorem and try it out, or get some divided factor out, you have multiple ways of figuring it out. But if you get a 0 for the remainder of the synthetic division, then you can confirm that it is a factor. So we have let P of x equals x cubed minus 7x plus 6. We don't have an x squared, so I'm just going to go ahead and write 0x squared in there. They're asking us to show that P of 1 is equal to 0 and use the factor and use this fact to factor Px completely. So we're going to use the factor of 1 to prove that this is a factor. So we're going to go ahead and do 1, 0, negative 7, positive 6, factor of 1. We're going to bring down that 1. 1 times 1 is 1, 1, 1, negative 6, 0. So that means we have, if x equals to 1, we can say that we can subtract the 1, and we get that x minus 1 is equal to 0. So x minus 1 is a factor. Now, if you were to keep going to factor it fully, you would end up with an x squared plus x minus 6 is equal to 0. And you need numbers that work out to negative 6 and positive 1. So you have 1 and 6, 2 and 3. You can do positive 3 and negative 2. So we get x minus 2, x plus 3. But you can't forget that x minus 1 factor. And then you have factored the entire cubed equation into all simple terms of x minus 1, x minus 2, and x plus 3. Now you can get all of the x's by equaling each parenthesis to 0, and you would get x minus 1 is equal to 0, x minus 2 is equal to 0, and x plus 3 is equal to 0, which will leave you with x is equal to 1, x is equal to 2, and x is equal to negative 3. So if they say you have to factor it completely, you can go ahead and do that by factoring out the remainder of what you got out of the synthetic division, factor it out like you usually would, and you can actually get all of the factors that you're missing. But x minus 1, you can't forget it because it's also a factor. You just happen to divide it out before you did anything else. So they're asking us to divide this and find what the remainder is of negative 4. If they ask it like this, it means that it's the remainder theorem. So we're going to go ahead and do 3, 4, negative 5, and 7. We didn't need to add any zeros because it goes from cube to square to 1 to none. So go ahead and bring down that 3. So you get negative 12. This is negative 8. Positive 32, positive 27, negative 108, and then we get negative 101. Since they're asking just for the remainder theorem, we can say that P of negative 4 is equal to negative 101, and that will be your solution. Here we have an x cubed. We don't, actually, that should be an x squared. Let's put 7x as 7x squared, and then 5x, then negative 6, and they're asking for P of 3. So it's going to be 2, negative 7, 5, negative 6. I'm going to go ahead and do 3. So we're going to bring down the 2. This is going to become 6. -1, -3, 2, 6, 0. Now, because they're asking for the remainder theorem, we will look at the remainder. It happens to be 0, so P of 3 is going to equal 0, and that would be your solution. You guys have a WebAssign homework already on Canvas, and it's already on WebAssign. You guys can start it for the last couple minutes of class. As well as, this would be it for today's notes.